All right, this video is on function operations and compositions. So what you can start off by doing is pausing the video and doing the 3 opener problems and see how you did. All right, here are the answers. Let me paste those there. All right, here are the answers to the 3 opener problems. If you need to pause it here and look over the work, feel free to and see if you have questions. All right, so this set of notes is on function operations and compositions. We're going to start with function operations. So in the first 4 problems here, you are using the following prompt. It says let f of x equal 4x minus squared and g of x equal 2x minus 3, and it's find the following and simplify. So the first one asks us to do f plus g of x, which is the same thing as f of x plus g of x. So that's exactly what you're going to do. Is you're going to take the function f, which is 4 minus x squared, and you are going to add to that the function g, which is 2x minus 3. All right, so in order to add these 2 functions, all you have to do is combine like terms and write it in standard form. So writing it in standard form and combining like terms, I'm going to start with the negative x squared, and then I have a 2x, so I'm going to do plus 2x. And then a 4 and a negative 3 is plus 1. So there is my f of x plus g of x, or f plus g of x. Negative x squared plus 2x plus 1. Now in the next problem, it asks us to do f minus g of x. So similarly, we are going to write down the function f, which was 4 minus x squared. And this time we are going to subtract g of x, 2x minus 3. Now you have to remember to subtract everything in g of x. So the way I make sure that I remember is that I change it to addition and then distribute my negative. And that way it's just addition. All right, combining like terms again here, we have negative x squared. We have minus 2x because we're subtracting that positive 2x. And a 4 and a positive 3 is 7. So we have negative x squared minus 2x plus 7. Okay, moving on to the next one, it says f times g of x. So this is the same thing as f of x times g of x. So I'm going to write down what f of x is, 4 minus x squared, times g of x, which is 2x, was it minus 3? Yes, minus 3. And now I'm going to multiply these 2 functions. So I'm just going to use the distributive property. Using the distributive property, we have 4 times 2x is 8x. Okay, and then we have 4, so I just did 4 times 2x is 8x. 4 times negative 3 is negative 12. And now I'm going to distribute this negative x squared. Negative x squared times 2x is negative 2x cubed. Negative x squared times negative 3 is positive 3x squared. Okay, so now if I look, there's no like terms to combine, but I can write it in standard form or the exponents in descending order. So I have negative 2x cubed plus 3x squared plus 8x minus 12. Okay. All right, the next one we have here is f divided by g of x, or f of x, 4 minus x squared, divided by g of x, 2x minus 3. So in order to simplify a fraction, we have to cancel out, that's an air quote there, any common factors. So in order to do this, the numerator has to be factored and the denominator has to be factored. So on this one here, the numerator is factorable. That is a difference of squares. So that's 2 plus x and 2 minus x. And then my denominator is not factorable. That's 2x minus 3. So if you look from numerator to denominator, there is no common factor. So this is our final answer. Now, if you would have left it like this is also an acceptable answer because it wasn't simplifiable. If it's simplifiable, though, you have to simplify it. All right, next we have the exact same 2 functions here, but instead we have find f plus g of negative 3. So there's actually two ways of doing this. I'm going to show you both ways, but it's up to you. So you can do f of x plus g of x and then plug in negative 3 into that function, or you can plug in negative 3 to f, negative 3 to g, and then add those two values. So I'm going to start with find f plus g. So I'm going to do f of x plus g of x, which we already did. That is right here. Okay, so I'm just going to copy this and paste it over here. And I'm going to delete. Okay, so that's f plus g. And then now I can plug in negative 3. So I have that negative 3 squared plus 2 times negative 3 plus 1. Negative 3 squared is 9. Then I have to multiply it by negative 1. So that's negative 9 minus 6 plus 2. So that's negative 15 plus 1. I don't know why I said 2 plus 1, which is negative 14. So this is negative 14. Okay, so that's one way of doing it. Then I'm going to quickly show you another way, and then I'm only going to do these one way because I don't feel like doing multiple sets of work. So what you could do is you can find f of negative 3. So plug negative 3 in here. 4 minus negative 3 squared. That is 4 minus 9, which is negative 5. And then do 2 times negative 3 minus 3. That's negative 9. And then it says to add them. So negative 5 plus negative 9, negative 14. So either one works. It doesn't matter which one you do. All right, next one we have g minus f of 4. So same thing. You can do g minus f and then plug in 4, or you can plug in 4 to each and then subtract those values. I'm going to do g minus f and then plug in 4. So g was 2x minus 3 minus f, which is 4 minus x squared. You might be asking yourself, why aren't I using my work above here? It's because this was f minus g and not g minus f. All right, remember it's subtraction, so I have to subtract both this, and then I can add the opposite, or I just added the opposite. So we get positive x squared plus 2x minus 7, and now I can plug in 4. So I have g minus f of 4 is plugging in 4 squared plus 2 times 4 minus 7. That's 16 plus 8 minus 7, which is 17. Okay. All right, we have f times g of 5. I already did f times g. It's right here, right? So I'm going to copy that and paste it down here. And now I'm just going to plug in 5 everywhere I see an x. So negative 2 times 5 cubed plus 3 times 5 squared plus 8 times 5 minus 12. And now I just got to clean that up. So I have 5 cubed is 125. 125 times negative 2 is negative 250. 5 squared is 25. 25 times 3 is 75. 8 times 5 is 40 minus 12. And then a little bit of more mental math here. Negative 250 and 75 is negative 175. Plus 40 is negative 135. Minus 12 is negative 147. Okay. All right, next one, g divided by f. We did f divided by g up there, so now I have to do g divided by f, which is 2x minus 3 divided by 4 minus x squared. But we said that wasn't simplifiable already. If it's not simplifiable when it's flipped, it's not simplifiable this way either. All right, so we're going to plug in negative 3 here. So we have 2 times negative 3 minus 3 over 4 minus negative 3 squared. So that's negative 6 minus 3, which is negative 9. This is 9 right here. 4 minus 9, which is negative 5. A negative divided by a negative is a positive, so this was 9/5. Okay. All right, our next is that composition of functions. So we did operations, and now we got compositions. So what you're going to see with these problems is something like this. This says find f of g of x. F of g of x. This is another way of writing it, f of g of x. They say the same thing. And what that means to do is to take the function g and plug it into f. This here says g of f of x. This also says g of f of x. This says g of f of x. This says g of f of x. They say the same thing. And what you're going to do with this one is you're going to take f of x and plug it into g. Okay? So let's go ahead and try a few of these problems. But before we do that, these first two, 9 and 10, are just reviews, so you can go ahead and pause the video and try them on your own. The first one says find f of k plus 1. So go to f, wherever there's an x, plug in k plus 1 instead. So we have 3 times k plus 1 minus 4. Distribute your 3. Combine like terms, and you have 3k minus 1. This one here, find g of x minus h. So here's g, and wherever there's an x, you're going to write x minus h instead. So we have x minus h squared, and then minus 3. Expand x minus h squared. Remember, that's x minus h times x minus h, and then multiply that out. So that's x squared, negative xh and negative xh is negative 2xh, plus h squared minus 3. And then there's no like terms to combine. There's my final answer. All right, moving on to the next 4. All right, so this right here says find f of g of x. So take g and plug it into f. And they say the same thing. It doesn't matter which way it's written. So we're going to take the function g, which is right here, and we are going to plug it into f wherever we see an x. So we're going to write down this 3. Instead of writing that x, we're going to write x squared minus 3, and then minus 4. So once again, we have that 3x squared minus 3, close the parentheses, and then minus 4. Clean this up. 3x squared minus 9 minus 4. And then we have 3x squared minus 13. So that's f of g of x. For number 12, it's find g of f of x. So this means to take f and plug it into g. Take f and plug it into g. Okay, so we're going to take f. I'm going to use a different color here. Here's f. And we're going to plug it into g. So right there. So instead of writing that x, we're going to write 3x minus 4, and then we're going to square it. 3x minus 4, and we're going to square it. But then we have that minus 3 right there. All right, 3x minus 4 squared is 3x minus 4 times 3x minus 4. So we're going to multiply that out. 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. So is that. So that's negative 24x. And then negative 4 times negative 4 is positive 16 minus 3. Combining like terms, we have 9x squared minus 24x plus 13. And there is your final answer. All right, 13 says find f of g of 3. So once again, you can do f of g of 3. So you can find g of 3, whatever that is, plug it into f, which is more work than what we're about to do because we already did f of g. It's right here. And then we're just going to plug in 3 into that. So we're going to do 3 times 3 squared minus 13. Much faster. That's 9. 9 times 3 is 27 minus 13, which is 14. Okay, and then this next one here, same idea. This is g of f of x, so we're going to plug in negative 4 to that. So we're going to do 9 times negative 4 squared minus 24 times negative 4 plus 13. All right, a little bit of mental math here. That's 16. 9 times 16 is 144. Negative 24 times negative 4. 48 doubles 96, and then plus 13. Okay, so then we have 144 and 96, which is 150, 240 plus 13 is 253. You can hear me mental mathing it, right? Okay, we have 2 more sections left, but they have the same idea as of directions. It's find the composition and then find the domain of that composition, okay? Since it's the domain of a composition, we do have some rules to follow, which I've written down, but let's first worry about finding f of g of x and g of f of x, and then I'll say what those rules are when we get to actually finding the domain. All right, so f of g of x means take g and plug it into f. So here's g. We're going to plug that into f right there. So we have the square root of, instead of writing this x right here, we're writing 4 minus x squared. And we can't simplify that, so all done. There's your answer to that one. All right, next one here, take f and plug it into g. That's g of f of x, right? Take f, plug it into g. So where's f? Here's f. We're going to take this. I need to erase what I wrote all over it because it confuses me. Take f and plug it into g right here. So we have 4 minus the square root of x, and then that's squared. So we can clean this up because the square root squared cancels each other out. So we just have 4 minus x. Okay, so now we can find the domain. So since it's a composition, you can't just look at the final answer, okay? So what you're going to have to do when it's a composition is you're going to have to check the domain of the inside function. Then you're going to have to check the domain of the new function. Then you're going to use that to write the domain, okay? So if you look at this one, we have to check the domain of the inside function, which is g of x, okay? So if you look at g of x, right here, g of x domain, it's a parabola. It's all real numbers. So the domain of g of x is all real numbers, negative infinity to positive infinity, because it's a parabola. There's no restrictions. But then you also have to check the domain. That's what it says right here. So I did the inside function. That you also have to check the domain of the new function. So looking at the new function, you have square root of 4 minus x squared. Remember, we have restrictions on square roots. We can't take square roots of negative numbers. So we have to say that 4 minus x squared has to be greater than or equal to 0. So we're going to factor this. 2 plus x, 2 minus x is greater than or equal to 0. Then we're going to find our critical values. We get x equals negative 2, x equals positive 2. And we're going to put those on a number line. Remember, when it's a quadratic like this underneath a radical, we have to visualize where the function is, the radicand is positive and negative, so that we can get our solutions, right? So we have negative 2 here and positive 2 here. Because it's greater than or equal to, we are including negative 2 and 2 in our solution set. And now we have to see if we're including numbers less than negative 2. So plugging in negative 2, plugging in something like negative 3 into the inequality. If I plug in negative 3 here, 4 minus 9 is negative 5, is negative 5 is negative. So now I'm going to check values in between negative 2 and 2, so let's check 0. 4 minus 0 squared is positive. And now I'm going to check values bigger than 2, so like 3. If I plug in 3, 3 squared is 9, 4 minus 9 is negative. So remember, I can't take the square root of negative numbers, only positive numbers, so these are my solutions. So that would be all values from negative 2 to 2, including negative 2 and 2. All right, next one. Domain of, whoa. So this right here didn't give me any more restrictions, right? So it might have given me more restrictions, but it didn't give me any more. It's saying, everything works. If it had restrictions, then I would have to incorporate them in the domain. All right, g of f of x. So we're going to look at the inside function first, which is f. This does have restrictions, right? F does have restrictions. You can't take the square root of negative numbers. So for the domain of f of x, x has to be, I should put dots instead of equal signs. There we go. X has to be greater than or equal to 0. So in other words, 0 to infinity, all right? Now, if you look at g of f of x composition, this has no restrictions. So if you just look at that, you might accidentally say, oh, all real numbers. But because there's restrictions on the original inside function, f of x, the domain is 0 to infinity. Okay, so the moral of that is just check the inside function and the final function. All right, one more set and then these notes are done. So h of j of x, so take j and plug it into h. So here's j, and we're gonna plug it into h right there. So that is 1 over x squared minus 4. Okay, let's just go straight to the domain on this one. So let's do that, then do the domain. Okay, so we're gonna do the domain. So for the domain, we need the domain of j of x, and we need the domain of the final function. So the domain of j of x, if you look at j of x, it's a parabola, there's no restrictions, negative infinity to positive infinity. So that's not giving us any restrictions. But if you look at the final function, there is restrictions because our denominator cannot be equal to 0. So we're gonna say x squared minus 4 cannot be equal to 0. So x squared cannot be equal to 4. So x cannot be equal to positive or negative 2. So now we got to think about what that looks like on a number line. If you want to draw it to help you visualize it, you can. Or you can just think about what it looks like, right? So if it can't be negative 2, it can be anything less than negative 2. So that's negative infinity to negative 2. Can't be negative 2, it can't be positive 2, but it could be anything in between them. So negative 2 to 2, and it can be anything bigger than 2. So once again, if you want to draw this on a number line to picture how it looks, like this is negative 2, this is 2, open, open, all this works, all these work, all this work, that's fine, but that's it. Okay, so there are restrictions, and here are that's your domain. All right, last one. J of h of x. So we're going to take h of x and we are going to plug it into j. So we have 1 over x minus 4, and then this is squared. And then we want to expand that out here. So that's 1 over x minus 4 times 1 over x minus 4. Multiply your numerators, multiply your denominators. We get 1 over, we multiply these out. We get x squared minus 8x plus 16. So there's your function. And then we want to look for domain restrictions. So if you look at h of x, the denominator cannot be equal. So domain of h of x, the denominator cannot be equal to, the denominator cannot be equal to 0, so x cannot be 4. So x can't be 4. How does that look in interval notation? It can be anything less than 4, and it can be anything more than 4. Now let's look at the domain of the j of h of x. This is j of h of x. If we factor that the denominator, it factors to x minus 4 times x minus 4, which still gives us the restriction x can't be 4, which is this. So our domain is the same. It's this. Copy, paste. This is our domain. All right, that's it for today on operations, function operations, and composition.